muted.
Good evening, everyone. Welcome back to Java training. So let us get started. Today we will try to understand what are generics. Okay, this topic is very important, as I always mentioned before. This topic is very important. Okay, so let us try to understand the basics of generics and try to implement them. So I would like to kind of like take up any questions during the session. If you have any doubts on or if you need any clarifications on any of these topics which we are discussing currently. Okay, so let's get started. So today, as I mentioned, we will discuss about generics, and in our last class we discussed about annotations. Right, so let us start with generics. So what are generics? So generics are nothing but parameterized types. Parameterized types are classes which are parameterized. We will see what is this parameter and all. Okay, why do we call this as a parameterized, and what are so how to create actually a generic, okay, generic type, in fact. Okay, so what does this help us in doing? It helps us in creating classes, interfaces, methods, and others, in which type of data is passed as parameter to the class. That is, type of the data on which a particular class works on or operates on is passed as parameter to the class itself. Okay, that is, for example, you have class A. Okay, say you have some methods which operates on integers. Okay, integer object. Okay, some method. Okay, it operates on integer object. So generics, we will define a generic class which takes some type, okay, some parameter. To that particular parameter, we will pass integer as argument. Integer is the data type, right? It's a class. Okay, class representation of int, primitive type int. Okay, so we will pass this data type or integer class type to this particular class while creating an object of generic type. Okay, so in that case, what happens? This particular class, I'll explain these things in a better way with an example. Okay, let me just explain this theory part. Okay, so what exactly is parameterized? The type of the data on which a particular class works is parameterized. Type of data. This is important to remember. Type of data being operated. Okay, type of data being operated by the class is passed as parameter or argument. While declaring, you specify it as a parameter. While calling or while creating an object, you pass arguments. Okay, you pass arguments. So what are the advantages of using this generics? We can create a generalized class or interface or methods. Okay, with respect to the type of data that is being operated by the class in a type safety manner. We will see with an example what does type safety means. Okay, we will see an example to understand what is a type safety. Okay, so all these things are handled in a type safety manner. Okay, all these things, whatever the type of data that is being operated right by the generics, they are operated in a type safety manner. Okay, so before introducing, Java 5 generics were introduced from Java 5. Okay, generics were introduced from JDK 5. Java 5. Okay, generics were introduced from Java 5. Before that, were we not able to create a generalized classes, interfaces, and all those things, methods, and all those things? Yeah, we have the way to create those things by using what are called as object references. Object references. Yeah, Kavita is telling overloading methods to avoid overloading methods. Yeah, that is one way, Kavita. Yeah, we'll get to that particular point after some time. Okay. Today we'll discuss only about the classes. Okay, how to parameterize a particular class, and then different attributes associated to that particular parameter, the type parameter. Okay, and tomorrow we will cover other topics like how to create a generalized or parameterized method and interfaces, all those things. Okay, we will see that tomorrow. So before JDK 5, all the methods to create an generalized class or interface or method, we used to use object references. Object is, we all know that object is a superclass of all Java classes. Okay, so when you define a reference of type object, you define a reference of type object, it can refer to any object. Okay, any object, any type of object. It can refer to object reference. Reference created, references type of object. References of type object can refer to any object types. Objects, okay. So using these object references, we used to create generalized classes, okay. Generalized classes which can take, which can operate on any of the data type. For example, if I want to operate on integer, we can pass an integer argument, and we can work on that integer object. Okay, if you want double, we can use we can work on double object. Okay, similarly, our string means string, we can work on strings. So using this particular object, because object can object reference, the particular object reference can refer to integer object or double object or string objects, or whatever you can think of, right? So there are some disadvantages, or there are some kind of challenges when we use this particular object reference. To avoid all those things, the main thing is the type safety. Okay, the main thing is type safety. Okay, to avoid all these things, so they came up with Java people came up with concept called generics. Okay. So any class, interface, or method that operates on a parameterized type, right? Any class, interface, or method that operates on a parameterized type is called as generic or generic class or generic method. It is called as generic type. Simply generic type. Okay, it is called as generic type. It is simply called as generic type. Okay, anything which you declared as which takes parameterized type. Parameterized type is called as generic type. Okay, let us move on. So this is one example. Before getting into this one, let us see a non-generic example. Okay, in the sense, let us see an example with okay. So this is a generalized class. Okay, so here generalized means we are not using parameters to pass the type parameters. Okay, we're just using objects, references of objects. Okay, just carefully observe. So we have here this is a generalized class. It has one instance variable of type object. OBJ is of that particular type. Okay. So we have a constructor which again takes an object of type OBJ, and we assign that one here. And through this method, we get this particular object. Okay, this object. And then if you want to print the type of the object, yesterday we discussed about get class and get name, right? Get class that get name. That is, it returns an object of type, class, object of type class, and on that particular class we can call on that object we can call get name method, which will return a string representing the type of the object. Okay, this represents the type of the object. This represents the type of the object. Okay, here we are using object references. Object is a class. These are its references. Okay, all wherever you are seeing, they are all object references of object, so that we can whenever we pass some object here, okay, that will be assigned to this particular object, and then we can get that particular object and then print the type of get the type and then display the type of that particular object. Say for example, if I while creating an object of type generalized class, okay, generalized class by passing an integer object here, okay, integer object. All these things will refer to integer object, right? All these things refer to integer object. So when I get that particular object, it returns the generic object, that is the object type object, but we have to cast it to integer because it's an integer object. Okay, let us see that example also. Just a demo of the generalized class. Test how to test a generalized class. Okay, so this is our generalized class. Okay, this is our generalized class. So what are we doing here? So we are creating one generalized class, okay, and then passing 10 as its argument. Constructor. This is our constructor. We all know what is a constructor and why do we use constructors. Okay, so we are passing 10 as argument, but generalized constructor takes an object of parameter of object. So this is a primitive literal, right? Int is 10 is int. So how does this object takes 10? It is not possible, right? It should not take. Can anyone tell me why it is accepting 10? Can anyone tell me why it is accepting 10? 10 is a primitive data type, right? 10 is a primitive data type. Yeah, Kavita is telling it is integer. Yeah, Kavita, go ahead. Explain. What is integer? Yeah.
I mean, it is taking an object, so integer is also an object, like auto boxing it is doing.
Okay, good, great. Yeah, that is what. Yesterday we were discussing, right? Atif also has told the same thing. It is it auto boxing? He's asking, is it auto boxing? Yes, exactly. It is an auto boxing. Okay. So this particular int will get converted into integer object that we discussed in our last class, right? Last session. Integer object, and then that will get assigned to this particular object, which is defined in your generalized class constructor. Okay. Then we will call get object method on this GC. Okay. Since this returns an object of type object, okay, it returns an object of type object, we have to cast it to integer, because what did we pass here? We passed an integer, so we have to cast it to integer to get that particular object. Okay, we store it in X. We can just display the type and then value. Okay, So what are we doing here? We are first passing an integer. We are getting that object. So what exactly happens here? So what exactly is happening here? So we are passing an integer here, an object of integer. Okay. Now OBJ refers to, that is constructor parameter. OBJ refers to, let me put reference like this, refers to integer object. OBJ refers, okay. So we are assigning, here we are assigning this object, that is instance variable, to this one. So now instance object, okay, instance variable OBJ, okay, instance variable OBJ, this is our constructor parameter. Instance variable OBJ will refer to the same integer object, int object. Okay, remember we are dealing with objects only here. Okay, we are dealing with objects only. So when we say get object, we will get a reference to this integer object. We'll get a reference to this integer object, but the type of the object is object. Okay, even though the reference, this is the reference, this is the this particular whatever we are returning here, it is referencing integer object, but the type of reference variable is type of the reference variable which we need to declare to get this object is object only. Object, because it is giving the return value is object only. So the get type, it returns a string. This is straightforward. Okay, it returns a string and then we will display that type. Okay, so here it is very important to remember we are passing object here. Okay, we are passing object. That is why we have to typecast. That is why we have to typecast here. That is why we have to typecast here, because we are getting object. So we have to typecast it to get the respective object. Okay, since this is an integer, unboxing happens automatically. When we try to convert it or cast it to integer object, auto unboxing happens. Okay, so in x we will have value x, we will have a value 10. Okay, now when we try to print the type, it will display automatically, it will display integer. Even though we pass the primitive type, it will display integer. Okay, so similarly, when we pass double, we have to cast it to double. When we pass a string, we have to cast it to string. Okay, and then we can get the type and then print the value. Let us try to print run this program. Let us try to run this program and see what exactly happens. Okay, we are getting the exact values. Okay, integer, the type object type, first object type is we have passed 10, that is why it is integer, and the value is 10. We got it by this particular method, get object, and we casted it, and auto unboxing happened automatically. Okay, for second object, that is GC1, we passed 20.1, which is by default it is a double. So the type is double and the value is 20.1. Okay, and third one we passed the string. That is why we casted it to string. Okay, this is string and we casted it to string. What happens if we don't cast it to string? Can anyone assume? Can anyone just take a guess? So what is happening? We are getting compile time error, right? So is there a way to remove this compile time error? obj, because this is throwing, or this is returning an object reference, right? Object reference, this reference, not the integer string or whatever the type that is referring. So because of that one, once you capture that here, if you want to print it, you have to kind of like cast it to string obj to get the value stored in that particular object. Okay, because this is an this G02 represents a string. Okay, so this is one thing. This is one thing. Okay, that is we have to cast it. When we try to generalize a particular class using object, every time when we do, we have to cast it. Otherwise, the data types will not be compatible, and then you will not be, I mean, you will get the exception or compile time error. Mostly runtime exception only. We will see one example, okay, how that generates compile runtime error and how that is handled using the generics. Okay. So this is our generalized class with object. Okay. Then let's see how we can implement the same thing, this particular logic. Okay, how we can implement the same logic using what is called as generics. Okay. Here, this particular logic. Okay. This particular logic. So let us see that one. Generic class. Okay. So here is the way you can implement a generic class. The same thing, whatever we have implemented in this generalized class, we have implemented in generic class. Okay. So here, what are we doing? We are passing a parameter to class itself. Class itself. This is similar to you can kind of like associate this with the methods, any methods, void, some method, and within this parenthesis you specify some parameters, right? Method parameters. You specify some method parameters, right? Similar to that one, to specify type parameters to a particular class, we use angle brackets. Okay, and we specify some variable. What are here we have specified t to represent type. Okay, so what, like say whatever, say for example, I have one method, void method, int I. Okay, so you can pass any integer argument to this particular parameter. Okay, but here what we can pass, this is you can call this as a placeholder for any integer variable, any integer value, right? Placeholder for any integer, placeholder for any integer argument, any integer value. Similar to that one, t will act as a placeholder for any valid type, valid Java type, any valid Java data type. Okay, any valid Java data type. But remember, we are talking only about objects. Okay, not primitive types. Not primitive types. Okay, we're talking only about objects. Okay, so here, while we will see an example how to create an object of a generic class and how can we pass a type as argument, type argument to this particular parameter, that is type parameter. This is called as type parameter. This is called as type parameter. Okay, so any type we can pass it to this t, and if I pass integer to t, all these objects will become an integer. These objects, all these things will become an integer. This will display integer. Type will be integer. Okay. If I pass double, that will be double. If I pass string, it will be string. Okay. Similar to like the way we have done it in our previous example. Okay. So whenever while creating an object of generalized class, that is this class, we passed a particular object, right? We passed a particular object. First we passed 10, that became integer, and then 20.1, that is a double, and then some string we passed it, that is a string. Okay, similar to that one, while creating an object, we can pass a type. Okay, pass a type to this t. Based on the type of this object will become that respective type. Okay, if I pass integer to this, this will be an integer reference. So here it will become, we are assigning an integer object to this particular reference variable, returning the same thing. Type, we are getting the type, and then we will print the value. So simple methods. Okay. So let us see a demo of our test of this particular class. We have generic class test. Where is that? Okay. So we have this particular class. Let us see what we have in this particular class. Okay. So similar to whatever we did for object, right? We have the same thing here. Okay. Except for some syntax changes, everything is same. Okay. So within this angle bracket, we are passing the type. Okay. Not only while creating, we can create the object or reference variable with like this. Okay. Okay. While creating a reference variable, we are specifying the type within angle brackets. Type within angle brackets. This is important. Okay. So this is with this angle bracket, we can safely assume that it is through this within this angle brackets, we can pass type parameters. We can specify type parameters. Okay, we can specify type parameters. Okay, so we are creating GC here. GC is an object of this particular type. Okay, we are creating an object of generic class by passing integer as type argument and creating an object and assigning the reference to GC. Okay. So here, if you note, this is a constructor part, right? This part is constructor. In constructor also, what did we do? In constructor also, what did we do? We specified the type. Okay, is it mandatory to specify this type? Of course it is mandatory, because this particular object, this is a reference to an integer object, okay, where you can store an integer value. Okay, so for Java should return an object which is of same type, integer, which is referring to the same integer, okay, integer type. It should return a reference to an object which refers to an integer, not any other type. Okay, that is why it is mandatory to specify the type, or you have to specify the argument, parameter type argument to your constructor as well. Okay, but if you see here in the class, you don't do any such thing. Okay, so here it takes the t parameter. So But here, while declaring a class, you have specified the type parameter, but here you have not declared like that. Say for example, the syntax is not like this. It is not like this. Okay, this one is not like this. Where do you specify that one? While declaring the class, just after the identifier, you specify angle brackets. Within that, you specify one particular variable, and then you create the same object, and then here for constructor you don't specify anything like this. Okay, that is wrong. But while creating an object, you are passing the type argument. You are specifying the type argument in constructor as well. Okay. So this is important. So what did we discuss just now? Generalized class integer reference, that is GC. Okay, then reference is equal to generic class T integer, and you pass a value to that constructor. Okay, that is what it takes. We don't have any default constructor, so we have to pass some value to this. So this value should be of type whatever we specify there. Okay, that is why we have passed 10 here. That is why we passed 10 here. So this will, as we just discussed a few minutes back, this will get converted into integer object. That is, boxing happens, and then when you pass integer to this T, this is what is our T, right? This is where we specify the type of object. So when we pass integer to this particular parameter, that is type parameter, all T objects will become integer objects. Okay, we mentioned like the type of this T will be, it is a placeholder. We just mentioned, right? It is a placeholder for any type that we pass while creating an object. This is the type integer we passed. Here also we have passed integer. It returns an object of type integer. Okay, generalized class object of type integer. Generalized class object or generic class object of type integer. Okay, of type integer. This is very important. So of type integer. So all these things refer to integer type. Okay, now T will, it is similar to like you replace all T with integer. Okay, so this will become like public class generic, okay, integer, private integer, obj, and all assume similarly like this will become integer, this will become integer, and this will give integer java.lang.integer, and then this will give you the value. Okay. Anyone has any questions? Yeah, Kavita has. In Java 7 we can put only empty angle brackets. Okay, in Java 7 is it? Okay, fine. So what is Kavita telling is, let me copy that and paste it. Okay, what Kavita is telling is, in 7 we can, there is no need to specify this particular argument or this type. We need not have to specify the type here because already it is derived from this particular while declaring your reference variable itself. That's what she is telling. Let us try that as well. Okay. Yeah, correct. Whatever she told is correct. Okay. So so we need not have to specify. That is not a mandatory thing. So you can eliminate writing the type here because that is derived from this particular while declaring an reference variable, right? With this only they will declare. I mean, this particular type will be derived. Okay, this type will be derived. That is why here you need not have to specify. But still, okay. But still, we have to have this particular angle brackets, right? Let's remove this and see. This is also working. Okay, so this is also working, but it gives some warning. Okay, saying like the expression of type generic class needs unchecked conversion to conform to generic class. Okay, so that is why it is. It's at least this will be a correct one. Okay, correct syntax. Okay, so then similarly we did the same thing for double and string. Okay, so we can do the same thing here. Okay, anyway, that is done. We never have to think about it. This is allowed. Okay, so the type is derived from this particular part of your object creation. That is your reference variable declaration. Okay, so here also we have created three. Here we created three objects. One is the GC. Let us comment this particular part. Don't want this. Okay, we created GC class GC1, which refers to double, and GC2, which refers to string. Okay, let us try to run this program. So similar to what we got, with generalized class, we got the same answer, right? The type is integer 10, double 10.2, string generic class. That is the name of the type. Okay, that is the value that we passed. Here is the value that we passed. Okay, the same thing. But what is the advantage? What is the advantage of doing this? The simple advantage or simple difference that we can see here is just a cosmetic difference that we can see here is if you compare these two classes, right? Here, every time we have to cast it. Whatever the object that we get, right? We have to cast it. Double and then string to get respective object, because we are returning an object. Here we are returning an object. That is why we have to cast it. Each and every time we have to cast it to integer, double, string, or whatever we have done. But the same thing is not done in this case. So we are directly accessing it and then assigning it to respective data type. Double, GC1 get object, string, GC2 get object. Okay, all these things, the casting, all these things is taken care by. Who takes care of all these things? Here we are doing it manually, right? Here we are explicitly specifying or typecasting the object that we obtained from get object method. But who is doing that for us here? Who is doing that for us here in this case? The Java itself. Java is doing the implicit. All these things, typecasting, all those things are done implicitly for us. Okay, that is part of your generics. Okay, so let us see what else we have. Okay, this is the same class which I wanted to explain. So whenever we specify a type parameter to a class, we specify within angle brackets and then specify one particular placeholder. Specify placeholder, we specify one placeholder. The type of T, the type of T will be derived from the type we pass as argument while creating objects. As we just discussed, the type will be determined. The type will be type of T will be the type that we pass while creating an object. Okay, hope you understood that one. and different things. Okay, so the same thing, whatever I explained, I put it in this particular slide. Okay, so here T is used as a placeholder. So that is specified within your angle brackets. The type will be the type that we specify when we are creating an object. Okay, so this particular class, this is called as generic class or generics or generic type. Okay, generic type. This is what is called as parameterized type. Parameterized type, because this is generic class is a data type. Okay, and we have parameterized that. The data type itself is parameterized. That is, the class itself is parameterized by the type. That is why it is called as generic type, parameterized type. Okay. So next, what do we have? We have created an object of type T. Okay. So when an object of type T is created, and the placeholder, the type is T is used as a placeholder for the actual type that is passed when we create an object of the class. Whatever we just discussed, the same thing I have put it in these slides. Okay. So here we have a constructor. Here also we have mentioned T. Okay. So again the same thing. Okay. If you pass an integer object, as we saw in our example, this will be an integer. Otherwise, it will double or string or whatever the data type that we pass it to the object. Okay. That is what the type of O is determined by T, which is obtained from the type that we pass it to integer. But in 7, as Kavita mentioned, in 7 we need not have to mention this, so that will be derived implicitly derived from your object reference. Okay. So it is the same thing. We can use T as argument to a particular or return type of a particular object. We can use T as return type of a particular method, or I can use the T. We will see when declaring the generic methods, right? That time we will see whether we can pass this T to this any of the methods. Okay. Okay. So the same thing, while creating an object, we specify, but this is not mandatory now. After the JTK 7, this is not mandatory. We can just do without that one. Okay, empty angle brackets. Okay. Okay. So this is how it looks. Say for example, when I pass integer as argument, this is how that the specific versions. Okay. Versions look like. I tried to type this in in Eclipse, but that was a waste of time. So when we pass an integer, T will become integer. Okay, T will become integer. We don't specify anything here. That is your parameter. So okay, T will become integer, and all these things. This will be referring to an integer object. It will be referring to an integer object. So when you try to get the type, you'll get java.lang.integer. Okay. Here, when you try to get, because this is a string, it will get java.lang.string. Okay, we get string as the return type for this get type, but this object will be referring to integer. Here, this object will be referring to string. Okay, but this is just for our understanding. Okay, the compiler will not create, or the Java runtime system will not create any different versions of this particular class. That is your generic class. Okay, there won't be any different versions of this generic class. There will be only one generic class, but the parameter, that is type parameter T, is replaced with whatever the data type that we pass while creating an object. This is called as erasure. E-R-A-S-U-R-E. This is called as erasure. Okay, so it erases this T, replaces this T with the type that we pass it to the object itself. While creating the object, whatever the type that we pass as the type argument, the T will be replaced, but the same class code remains. There won't be any multiple versions of generic class. There will be only one version of generic class, but only T will be replaced with the respective type. Okay. So that's what I mentioned here. That is called as erasure. So there won't be different versions of generic class. There will be only one version. Okay, with T, and with respect to the type of object that we create, this T will be replaced. Type of T will be replaced with the respective type. Okay. Okay, this is not no more valid, so you can just ignore it. Okay. So here also I mentioned it is necessary, but remember when you are using JDK7, this is not needed. Okay, this the type information to specify type information in constructor, right? That is not needed, but before JDK7 that is needed. Okay, so as per yeah, as per Kavita, I haven't checked this one. I think from JDK7 we can just specify empty angle brackets. Otherwise, we have to specify the type. Okay, say for example, if you have installed JDK6 in your system, and if you try to do this, it might throw an it might show you compile time error. Okay, if you try this one. Otherwise, that will be perfectly valid. Okay, so Kavita wants to say something. Yeah, Kavita, what is that generic?
No. No, I don't want to say anything.
Okay.
No,
So
it was for the before question, like one question you had asked, like how it is taking the value, like something. So I wrote generics is doing that thing.
Okay, fine. Yeah, and the type information that if we don't provide type information below JDK6, that will be a compile time error. Okay, that will show as a compile time error. This is one way of showing ensuring type safety. You will see an example like how generics provide type safety implicitly. Okay, implicitly. With an example, we will see what is type safety and how generic provides. We need not have to bother about type safety at all. By default, Java takes care of type safety when we use generics. Okay. So as I mentioned while explaining, generics works only with objects. We are only talking about objects. Okay. It won't work with the primitive types. Hint. Okay. For example, if you want to create generic class int gc is equal to new generic class of 10. Okay, this will not work because this is a primitive data type, and with the data type itself, boxing and auto boxing will not happen. Or auto boxing, auto unboxing will not happen. Okay, this is a data type that we have specified, right? Int is a data type, primitive data type. So for values, auto boxing and unboxing happens, but the type for the type itself, it will not happen. Okay, type itself, it will not happen. Okay, so it works only with the objects, but this is not a serious restriction for us because we have type wrappers for each and every primitive data type, right? For byte, we have byte. In one of the previous session, we discussed about this, right? Type wrappers. So for all primitive data types, we have corresponding type wrappers. That is why this is not a serious restriction for us. Okay. So with the use of auto boxing and auto unboxing, we need not have to bother about anything. Okay, we can, as we just created an object with the 10, as we just created an object with 10, auto boxing happened, and when we retrieve the value, auto unboxing happened. We tried to capture that value in X, right? This is primitive type, and auto unboxing happened, and we got when we tried to print the value of X, we got the exact value. Okay, so with generics plus auto boxing and auto unboxing, everything is taken care for us. like boxing and unboxing, typecasting. All these things are taken care of for us. But there is a major thing, that is our type safety. With all these things, right? The type safety is provided by generics. Okay, type safety is provided by generics. So we have created multiple objects, right? Say for example, so here we have created multiple objects here. Okay, GC, GC1 and GC2. Okay, so GC is referring to integer object. GC1 is referring to float or double object. GC2 is referring to generic object. Okay, these three are not type compatible. Okay, say for example, if I try to assign, okay, so say for example, if I try to assign this, okay, this will show compile time error. Okay, it is a compile time error. GC is this is of type integer, and we are trying to assign string object to integer object. Okay, which is not compatible. Okay, that is taken care by our generics. Okay, but whereas in this particular case, we are referring to objects. Okay, when we got this object, right? So that is the object itself. Okay, so we can assign. This is possible. Okay, this is possible. This is valid. It allows us to assign one object to another object because all are of type object, right? Or all are of type generic class objects. So this is our generalized class. So the type of GC is generalized class. Type of GC1 is also generalized class. Type of GC2 is also generalized class. Okay, as we have seen in our basic classes, one type of object can be assigned to another type of object. It just copies the reference, and both objects will be pointing to the same value. Okay, in the memory. Okay, that is why this is valid. This particular statement is valid. But when we try to get the object, we have to again cast it to integer because we know that this is an integer. GC is an integer and this is a string. Okay, so what we are doing, GC, it should have been okay, we have assigned it to GC, and the GC.get object, we know that it returns an integer. It is whatever the value that we pass is integer. That's why we have to cast it to integer and get the value here and then print that particular value. Okay, print that particular value. So is there any issue with this particular statement? Okay, I have just mentioned here. Okay, we have to specify when we assign this particular thing itself is wrong. Okay, because we are trying to assign the reference of string, the reference which is referring to string object. Okay, we are trying to assign it to an object that is used for storing the references of integer object. Okay, so now this will be pointing to integer, or the string, and we are trying to get the value of that string as integer. We are trying to get the string as integer and store it in integer y. Okay, so here if you notice, we are not getting any, we are not okay, it is not at all, compiler is not at all telling anything. Okay, it is not at all telling anything. It is perfectly valid. It is perfectly fine. Okay, it is perfectly fine, but we will face problem when we try to run this program. Okay, when we try to run this program, because here this is pointing to string. We have tried to cast it to integer and store it in y, and when we try to print the value, what will it print? What will it print? It can't print integer value, right? It is pointing to string. That is why it will throw class cast exception. So we were, if you notice, we were not able to capture this during runtime or compile time. Okay, while compiling that class, we are not able to capture at all because the compiler did not show anything. That is perfectly valid. Okay, that is perfectly valid because we are assigning one object reference to another object. Okay, so that is why we were not able to figure out whether there is any issue or not. Assume that there is a very critical application running in your production, and all of a sudden this particular condition, say for example, you have some business condition, business rules set up, and then for one particular value, the business rule becomes true, and the control enters this particular set of statements. Okay, control enters this particular set of statements. Okay, so critical application. Okay, so there will be like critical applications means they will have high what to say so high business impact. Okay, direct revenue impact. Okay, even if you delay in fixing the issue for few minutes, right, that will result in say for example millions of dollars of impact that can impact millions of dollars to the customer for whom you have coded or we have coded. Okay, so it becomes very, very critical for us to identify all these kind of issues, runtime issues, right, during your compile time itself. So the scenario which I was explaining, say assume that for some vague condition, till now nobody had faced this issue. Okay, but for one unfortunate day, somebody entered something and it entered this particular piece of code and it threw runtime exception. We know exception, right? That they are runtime errors. And this is a critical application. And we were not able to, when we see this piece of code, then we are seeing this piece of code, okay, and nothing is happening. So we are seeing, and it is the compiler is telling that the number is 32, line number is 32, and we are seeing this, and we are not able to figure out, okay, this is correct, and this is correct. We have to check carefully, okay, or this is the C, okay, we have to go, what is the type of this one, and then what is this type, and all those things we have to check, and then by the time we figure it out, it will be like some time, okay, and business would have already got impacted. The customer would have got around some millions of dollars of impact. Okay, so this kind of issues, that is runtime exceptions, right? Runtime exceptions can be avoided using your generics. Okay, all these runtime exceptions, they will become compile time errors. Okay, all those runtime exceptions, they will become compile time errors. Okay, so when I try to assign an object, this is GC is an integer, is referencing integer, and GC2 is referencing our string. Okay, when I try to assign GC2 to GC, it is showing the error. Okay, because both of them are not compatible. They are not types are not matched. Okay, they are type mismatch. You cannot convert one type to another type. Okay, this is an object which is referring to integer. This is an object which is referring to double. This is an object which is referring to string, unlike here. Okay, here GC is generic class, generalized class. Here also GC is generalized class. Here also GC2 is generalized class. All are of type generalized class, but here it is not that way. Okay, it is not that way. So here this is integer, this is double, this is string. All are of different types altogether. The type of this object is the type of argument that you passed to a generic type or parameterized type. So these are all not of same type. Okay, so this is how here itself. So you can when you are using your generics, here itself you can during your compile time or when you try to compile a program, here Eclipse is compiling for us. But when you are writing some normal editor, when you write a Java program using normal editor and try to compile it, that time during compile time you'll catch this error. Okay, what exactly is happening now? Earlier, before JDK5, what used to be a runtime error? What used to be a runtime exception that became compile time error? So isn't this an advantage? Isn't this an advantage? This is the advantage of using your generics. Advantage of using your generics. Okay, that is why it is preferable to use generics instead of using this way, generalized class way. Okay. Okay. So anyone has any questions till now? Please let me know. We will discuss. Yeah, Kavita has a question. Okay. So this is the question. She's not exactly question. She is telling some information. Okay. She is sharing some information. Okay. So this is what she is telling. Okay. We should not accept this one, right? Because we know this is a error. We know, while discussing our classes, right? Classes and methods, we know this is object type. Okay. Here the type is derived from this particular type argument. Okay. That is why here even if we don't specify as per JDK7, that is derived from this particular type argument. Okay, that is derived from this particular type argument. So we cannot store this value. Obviously, we cannot store this value because this is a double value or double object. Since we have integer, we have to pass integer to this constructor, not double value. Okay, that is why it is not allowed. So that is what the information which Kavita shared with us. So it will become a compile time error, right? While trying to compile this program, you can immediately see this in your Eclipse, okay? But not when you try to code using some normal editor. Okay, you can see this error. Let me erase everything. Okay, so you can see here. So it is showing the compile time error here itself. So let us comment this. So any other questions? Any other questions anyone has? Okay, so let us proceed then. Okay, this is what that meant. Okay, generic types differ based on the type arguments. That is what we just discussed. This is an integer. We cannot assign GC1, which is a double. Okay, So GC we cannot assign GC to I'm referring to the previous program. Okay, so this is string and this is double. Okay, these are all not valid. So generic types differ. So you cannot they are not type compatible. So that you can assign one reference to another reference. Okay, so that is not possible. With respect to objects, that is possible, but it is not valid. That will result in your runtime exception. Not always. If you take care of when you are using object, if you take care of everything properly, that may not result in compile time error. But in order to take care of those things, you have to be very careful, and lot of testing efforts goes, right? So all these things will matter. So when you use generics, you need not have to think about anything. Everything will be taken care of for us by Java itself. Everything is implicit. You need not have to worry like do I have to typecast it? This object is of type this particular type, whether it is of whatever the object that I am getting is of this particular type. Do I have to typecast it, or does this particular assignment will take result in runtime exception, or all those things? We need not have to worry at all. Most of the things are taken care by JDK, and some things we will figure it out during our compilation. Okay, that is why the important thing to remember is that is how generics provide type safety for us. Okay, generic provides type safety for us. So whatever we discussed, I have just put it in points here. So the typecasting has to be done manually in case of objects. Okay. So not in case of non-generic classes, that is which handles objects, which are done using objects, references to objects. Okay. But with generics, typecasting and other things are implicitly handled for us. And the main, it also creates the code, safer code. Okay. Because each object that you create, generic object that you create, are different from one another. Okay. So is it possible to have, is it possible to assign, I have one question, is it possible to assign, say for example, I have a generic class, GC is equal to some new GC, okay, let us take this one only, 10, okay. I have another object, class, integer, GC1 is equal to new GC 20. So is it possible GC is equal to GC1? Can anyone tell me? Did you get this question? Let me write it in a better way. So I have a generic class which takes integer as type parameter, type argument, and I have GC is equal to new generic class of 10. Okay, and I have another object. So Kavita is telling it is not possible. Let us try that one. Why is it not possible? Both are referring to integer only, right? One is 20, another one is 10. So we can assign, both are pointing to, this should be possible, right? Okay. So Kavita wants to tell something. Okay, yeah, Kavita, go ahead, Kavita. Before testing, I just want to give you a chance to explain. You don't want to tell anything? Okay. So let us try, okay? So we have this one and we have XY. Okay. So this is 20 and the XY is 20, GC is 10. Okay. Let us try to assign. GC is equal to XY. Should be possible, right? If you think it should be possible, because both are of type integer, right? So let us try to print the value. So we're able to print that value, right? It is just a type incompatible because the type parameter that we passed, right? It is type incompatible. The type incompatibility will come into picture only when the parameter type that you pass, right? Type argument that you pass are different. Okay. Only when you try to assign this one, which is referring to double, okay, and to integer, that is when you get compilation error. But in this case, both are referring to integers, so this should be similar to what we did here in this object. Okay, generalized class, right? GC, or it is like any object obj obj2. Okay, obj is equal to obj1. This should be correct, right? This should be correct. So we were able to display that particular value. Okay, we were able to assign and we were able to display that value. Okay, yeah. Okay. So is it possible here in our examples, right? We have created one generic class and we have specified one type parameter here, right? We have specified one type parameter. Can we specify more than one type parameter? Oh, Kavita is telling, no. Kavita, I think she misunderstood when we tried this one. So what she was telling is, so yeah, this is what, you mentioned while we were discussing about assigning values, right? That is what that is what I asked the question. I don't know whether I was my wordings were proper, but this is what I meant. Okay, but what Kavita was telling is, we will check for equality. Okay, so for what she was telling is, yeah, this is a good thing. Okay, let us try this one. Okay, and okay, so this one we know it will result. GC will result in 20. Okay, because we have assigned a reference to this one. Okay, can anyone tell me what happens if I do like this? Okay, let me try this one. So what will be the output of this one? Can anyone tell me what will be the output of this one? We are trying to check whether GC is equal to XY. Let us make this one as 10. Let me see whether anyone has typed anything. Okay, Kavita is telling false. Okay, Tina is telling yes. Okay, that means true. Tina is telling true, but Kavita is telling false. The result will be false as per Kavita, but true as per Tina. So let me ask Tina why she thinks that is true. Yeah, Tina. Why do you think you get the result true? Okay, Tina doesn't want to talk. Yeah, Kavita, go ahead and explain why do you think it is false?
Because they are objects and they are pointing to different locations, so I think they are not same. But if it was only the value, then it will be same. I think so.
Okay,
So it is
so
false because both objects are pointing to different location, memory location.
okay. What will happen if we try this one? Can we use this one? So what will be the result of this one? Okay, let us run this program and we will find out. Okay. Anyone wants to explain this one? What will be the result of these two statements? Anyone wants to think and tell what will be what are the results of these two statements? This one and this one, highlighted ones. Okay, so let us run this program. Okay, let us run this program and see what happens. What is the result? Okay, GC equals to XY is true. Both are resulting in true, but I was expecting this is false, as you mentioned, Kavita, and this is also this should result in true because equals always checks for the values. Equals method always checks for values. Okay, but this is also like what is happening now is whatever the reference that is there in XY, that is assigned to this particular reference. Okay, that is why it is like you are trying to compare this reference with this reference because both are same only, right? Both are same. That is why it is also true. Okay, let us try to compare this way. Okay, here also we have value 10. Okay, let us try to compare this one. Okay, I'm trying to compare this with this. Now this is GC and K is false, and this one is true. Obviously, even if you try with K, right, this one K, it will result in true. Okay, because GC equals K is false. This is obviously both are referring to different address locations. That is why this is false. But GC equals K, it is also giving false. Okay, so here what is happening? Only it is checking for both your type and value. Here it is only values are equal, but references are not equal. That is why it is showing false. Okay, so I need to check this one. Okay, but normally when you try this with other things, it should give equals should give. If they both have same value, they should give true, and they should give false because both are referring to different address locations, as you told. That is nothing but your reference. Okay, address location is nothing but we refer it as references. Okay, so this should result in false. This should result in true. But here I think they consider the type and the value. for this particular equals. That is what I think they have overwritten in that way. Okay, that is why it is resulting in false. This is also resulting in false because the value, but even if you consider the type and value, they are same. Probably they consider the location also. I'm not sure. Okay, I need to check this one. Okay. Okay. Let us move on to the next topic. So can we specify more than one type parameter? Yes, we can specify more than one type parameter. I think Tina told yes to that particular question. Okay, we can specify more than one parameter. So if you want to specify more than one type parameter while declaring a class, you just have to specify T, P, A, B, C, like that. Okay, so each parameter, type parameter, should be separated by a comma. Okay, but you can specify any number of type parameters. Okay, you can specify any number of type parameters. Let us take an example. Let us see an example of that. This is generic class 2. Here it takes two type parameters. We are similar to whatever we have defined before. The same thing we have defined, and then we have tried to execute. I mean, we have tried to implement those things. So since it takes two type parameters, we can give different types also while creating an object. Okay, integer and string. So in this case, what will happen, Kavita? Is it possible this way? It is possible here also. Okay, so we have to specify two types to we have to pass two type arguments to arguments while creating an object. Okay, here we have specified the integer and string, so we can get the object and object 1 and object 1 type, object 2 type, but it is not necessary that we should have different types all the time. You can specify different types all the time. You can specify same type also. The arguments passed, type arguments that you pass can be of same type. Okay. In that case, you can specify any number of arguments, type arguments, and any combination. So it can be same or any combination you can pass it. Okay. That will give the respective things. First object, second object, type here. Okay. Okay, we can specify more number of type parameters. So we have here how to specify the generic form, the syntax for defining a generic class. Since this will clash with whatever I used to use, like this. So I have used square brackets. Okay, access type, class, identifier, and then we specify the type parameter list. So we have, for first thing we have specified only one. For the second class we specified 2. Okay. Yeah. What is that, Kavita? You are telling yes. Okay. Fine. Yeah. So that is, and then we declare the class members. Okay. Okay. And then syntax for declaring a reference variable. So this is one, but this is not needed from JDK7. JDK7, this is not needed. Just mention empty angle brackets. Okay. So there are we have specified the types in our angle brackets. as parameter to class declaration. Okay, we have specified type parameter to class declaration, and we can, while creating objects, we can pass type arguments to this particular type parameter. Okay, while creating an object. So there are something called as bounded types. Okay, there will be some situations where you have to pass only specific types. Okay, specific types and their subclasses. There will be some scenarios where you have to restrict your whatever the type that you pass here. Okay, in these cases, right? In these cases, whatever the cases that we took here, you can pass any type, integer, string, or whatever the thing. Even if you want to pass object, you can pass object. If you can pass object, you can pass any object, any type. Okay, because the object is superclass of all the types that are available in your Java. Okay, so any type you can pass here, but assume that there is a scenario where you have to limit the types that you pass here, right, to only certain class and their subclasses. Okay, this is achieved what is known as bound types. This is achieved what is called as bound types. Okay, so how do we specify a bound type? We specify the type, and then we specify extends, and we specify the superclass. Okay, so whatever the types that we can assign it to T is like the superclass and their subclasses. And their subclasses. All other types are not valid at all. Okay, for example, you have there is one particular class called number. Okay, all your numeric types, that is your integer, your float, your byte, your short, all are subclasses of this particular number. Okay, so a situation arises where you have to you are creating a generic type and you are calculating something based on these numbers. Okay, you are doing some math on this on the objects that you pass or the type that you pass to the generic class. Okay, say for example class A, it takes T. Okay, whatever the methods that you have defined inside this, they are all math related operations. They are all math related operations. Assume passing a string type to this T and trying to do math on those strings. Will that work? It will not work, right? So in such scenarios, what you have to do, you have to restrict T to numbers. Okay, T to numbers. So how can you do that? Just by doing T extends number. Okay, class A. So now, what are the types that you can pass to this particular parameterized, this particular type parameter? Any type that is number and subclasses of number. Not only integer and float, it is anything you can pass. You have integer, you have double, you have short, you have byte, you have what is a float, you have double. All these things you can pass. Okay, so that is what you are bounding or you are limiting the types that you pass as arguments, type arguments to this parameterized type. Okay, so you are binding, you are limiting the types that you can pass as the argument, type argument to this particular generic class. That is achieved using your extends keyword with superclass. Okay, let us see an example. Okay, just for our reference, I just created one particular class, that is okay, this is our training, and then there are some subclasses of training, that is your UI training, Java training, and advanced Java training. Okay, all these three things. Okay, UI training, advanced Java training, and training. Training is the superclass of all these objects. Okay, that is advanced Java, UI training, and this one. Okay, so there is one particular generic class we have created using training. So let me check. I think I forgot what was that. Usually it should be training test, trainings test, Java training. Yeah, this is our bounded type implementation. So here T extends training. Okay, T extends training bounded type test. Okay, okay. So these are all our. This is our main class, which we main class in the sense our generic class, which actually extends training. Okay, which actually extends training. Here, this is the upper bound. This is the upper bound. That is this particular T. What are the types that we can pass to this T? It can take trainings. It can take Java training. It can take UI training. It can take advanced Java training. All these things you can assign. Okay, but apart from these types or the classes or the types, better to call it as types, we cannot assign any other types. Okay, so here is the test, bounded type test. Okay, that is all. So we were able to assign trainings, Java training, UI training, and if you want to assign advanced Java also, we can do that. Okay, this is also possible. Why this is not possible? Okay. Okay, there is some spelling mistake. That's why it is showing error. Okay, all these three things are possible. But when we try to assign the object itself, it is showing error. Okay, type mismatch, bound mismatch, it is saying bound mismatch. Okay, similarly, when we try to assign a string, it will say bound mismatch. Okay, any other type, it will not allow any other types, it will allow only all these 4 types. Okay, the upper bound we have mentioned as training, that is why it is allowing trainings and its subclasses. Okay, this is how you specify bounded types. This is how you specify bounded types. How do you specify? You specify the type, extends, and then specify a superclass. Okay, including this superclass, all its subclasses are allowed. All its subclasses are allowed. Okay. Okay. Let us see if we have any other things to discuss. Okay, so for these bounded types, yeah, there is there is no restriction like we have to specify only class types. Okay, there is no restriction like you have to specify only class types. We can specify class types and interfaces as well. Okay, you can specify both class type and interfaces as well. Okay, when you specify interface, the only types that can be passed as type arguments are the implementation of that particular interface. Okay, implementation of that particular interface. Say for example, you have class A and you have T extends some interface. Okay, so here you can pass any class that implements this particular interface. Okay, that is possible. So when specifying bound, that includes both class type and interface. Okay, or you can also specify multiple interfaces. Okay, you have to use what is known as ampersand operator. Okay, you have to use ampersand operator. Okay, so what does this say? When you say like it implements a particular class and interface, the allowed types are any class that that extends this particular class as well as implements this interface. It is plus. Okay, that is class, any class that extends from the class specified as well as it should implement the interface. Those are the types which will be allowed. Okay, let us see an example. I think I have one example. Okay, so this is my class subclass 1. Okay, and then my interface and my interface 1. So bounded class 2, bounded class. Okay, so here what is happening? Bounded class, I have mentioned T extends my class and my interface. Okay, T extends my class and my interface. So what are the things that you can pass here to this T? Any class that is subclass of my class and which implements my interface. It should do both. It should subclass my class as well as it should implement my interface, because we have specified and, right? That is how you connect both these two things, my class and interface. Okay. So what is the class that has implemented both? Okay, let us I forgot all those. Bounded type test, bounded class test. Okay, here if you see my subclass 1, okay, if you open that my subclass 1, that if you see this has this extends my class as well as it implements my interface. Yeah, 1 minute, Kavita, let me explain this one and I'll come to you. Okay, this extends my class as well as it implements my interface. Okay, so let us go back and try to do this one. Okay, so it is showing error. What is this my subclass? My class subclass. It just extends my class. Okay, that is why that is not allowed. Here what we are saying, it has to extend my class and it has to implement my interface. Okay, it has to extend my class and it has to implement my interface. Okay, so this is not doing, that's why it is my subclass only extends my class. That is why it is not allowed. My class subclass 1 extends my class and implements my interface. That is why this is allowed. Okay, so when we specify both class and interface, whatever the types that you pass, they should subclass that specified class as well as that interface. It should implement that interface. Okay. Yeah, Kavita, go ahead.
In that bonded class, T extends my class and my interface. It means that same, right? T extends my class and implements my interface.
Exactly,
Or
correct.
we have to write implements, or we can use and.
1 minute.
I mean.
Got it. I understood your point. So I think. So is there anything, any specific thing for in JDK 7? This is what I understand.
No, I mean
Okay.
I don't know about. I mean
Okay.
this and means and should be for the interface or.
For the
I mean
interface,
if
we
I
have to specify.
yeah.
Yeah,
Oh,
we have to specify that. Yeah, go ahead. Go ahead.
I
Go
mean
ahead.
if there are two interfaces, then I can put comma and put interface 2 like that. But
Yeah.
and is used for only for class and interface, or if you are
Yes,
using
it is used
class
for
and interface?
it is used with class and interface.
Oh,
Okay.
okay. Like
So that means it. Yeah, go ahead. Go ahead.
yeah, if I want to write T implements my interface and my class, I can write in that way. I'm just asking.
He implements my my interface.
My face and my class.
My class. This is not at all possible. Okay. The implements, I'm not sure. Okay. So I don't know whether we can use this implements keyword. We will try this. Now itself we will try. Okay. But implements my class and my my interface and my class, I doubt, because class should come first. Okay, I think for extends class should come first and implement. Let's try that one. Okay, why simply have confusion? Okay, let us try that one. Shows already it is showing error, right? Okay, this is not at all allowed. So first what we have to do is we have to use keyword extends. Okay, so when extends comes, the first thing that you specify is my class, that is the class type, and then you specify my interface. Any interface you can specify. Okay, if you want to specify one more interface, I think I have this my interface and my interface 1. Okay, the class should come first, and then after ampersand you should mention, you can mention my this one. What is that? whatever the interfaces that you specify. Okay. In this case, what does this mean? This class, whatever the type that you pass, right? Whatever the type that you pass, that should subclass this, and it should implement both this. Okay.
Hello.
One minute, Greta. So why is it showing? Saying some warning, type interface, my interface one is hiding the type my interface. Okay. So if it wants to implement both, right, you have to mention like here you are specifying two types and my interface. So in this case, you are passing two type parameters. Okay. But why? Okay, this should be valid. Let us try this one. Okay. Let me finish this one, Kavita. Okay. Welcome to you. Welcome to your point. My class will not be, it is not possible. So is there any other class which includes bounded test? Training. Implements my interface. We can use this one. Let us see. This is not allowing. Okay. So that means it should implement both interface one. Okay. So that is when this will become valid. Here also it is not valid. Right. Incorrect number of arguments. Okay. So what it is saying is any class that implements yeah, so this is what it is saying. Okay, you can pass my subclass one along with my sub. If you see here, this says, yeah, it says it extends my class, my interface, and my interface one. Okay, also what it is saying is, where is the test? Right, cloud dimension. So here we have mentioned my class and my interface and my interface one. So what is it is like it is it wants to it is taking this one as one parameter and this one as other parameter. So you have to specify the interface which implements this particular interface as well as a class that specifies or that subclass of my class and implements my interface. That is what I did. And also you can in this particular parameter, right, you can pass a class that extends my class and my interface, implements my interface and my interface one as well. Okay, that is what it is saying just now, which we checked, right? That is what it is saying. Yeah, Kavita, go ahead.
I mean, can you repeat once again because I got confused somewhere from.
Okay, so here is this definition, right? We are trying to create a generic class with we are specifying some limitation, right? Here, this is a bound type. This is a bound type, right? So what are we telling to this bound type? So T should be extending from my class and it should implement my interface, okay? And it should implement my interface 1 also. So what is happening is, if you specify only one class, okay, if you specify only one class that implements these two interfaces, and my class, it is showing error. Okay, so why? It is expecting one more type parameter for this interface. Okay, what does that mean? That means this whole thing is one thing, one type that you can specify, and the second thing that you specify, the second type that you can specify is any class that implements this one, only this interface. Okay, so let's see that one. So where is that? So here, see this my class one, my class subclass 1 implements all these things. Okay, all these interfaces. Sorry. Okay, and when you go back, if you remove this my IF, right? So remove that, it is showing error. Okay, incorrect number of arguments for type test class. So it is saying there should be one type parameter, class type parameter, and then there should be one interface type parameter. Okay, can you see this one?
Yeah, I mean, I have a question like T extends my class and my interface. So my class should implement my interface only, not my interface 1. It should implement both the interfaces or just my interface 1. So that.
1 minute. Let me. Okay, my IF IMPL. Okay, IMPL 1 now. 1 minute. 1 minute. I'll come to your question. Kavita, give me a second. My IF1 IMPL. Okay. Okay. Now you tell me. I will try to do. Okay. Tell me now.
Means I have that question like whether in my class should implement my interface or it should implement both the interface.
1 minute. 1 minute. I'll come to your point. Okay. This is your definition, right? My class and my interface, right? This is what you are expecting. This is what you, for this particular thing you want definition, right? Means you want explanation. Okay.
Yeah.
So
and
okay.
Yeah, and another one is that like it was showing that there should be two types. It should take two types in test class.
Correct.
So that should be the other should have only the interface. It should not have any class implementing that interface. I mean.
Okay, I will explain all those things, Kavita. Okay, so give me a second. I will explain all those things. What are the questions here? I got it. I'll explain all those things. Okay, let's start with this definition. Okay, so it is a generic type and it is a bounded type, not just a normal type. It is a bounded type. Why do we call this as a bounded type? We have set some limitations. Set some limitations to the types that we can pass. That is why this is bounded type. The limitation is specified in this part. Okay, so T extends. Okay, T extends my class and my interface. Okay, T extends my class and my interface. Okay, it means any class that extends subclass, that extends or that subclasses my class or any subclass of my class which implements my interface. That means, say for example, you have one class A which extends my class. Can you pass this type as a parameter to this? No, because A should extend my class as well as it should implement my interface. Okay, only classes that you can pass or only types that you can pass here is a subclass of my class and any subclass of my class which also implements my interface. Did you get Kavita?
Yeah, I got this one.
So say for example, I have class A which extends my class and implements my interface. Okay, only if class A is extending my class, that is not valid. It should satisfy this whole thing, then only it is valid. Okay, or any subclass of A. Okay, in that case it extends through A, it extends my class and it implements my interface, right? So any A in this scenario which extends my class and implements my interface as well as any subclass of A. Any subclass of A are allowed. Okay, only extending my class is not sufficient. It has to. That is why this ampersand symbol is there. And okay, extend my class and my interface. Extends my class and my interface. Okay, so now let's go to the other question, that is this is your second question, right? In this case, what happens, right?
Yeah.
Okay. In this case, first and foremost thing we need to think is there are two parameters. Okay, this is your interface, this is your class. Interface type. Okay, so there are two type parameters here. This is the one, this is two. Okay, so what are the things that you can pass here is class that extends my class, implements my interface, and or my interface one. Okay, it is and or. They are also allowed. Okay, if a particular class extends my class and implements my interface, that is allowed for this particular type parameter as argument. Okay, even if it implements my class interface, my interface one, that is also allowed for this class type argument, allowed as class type argument. Okay, even if it implements extends my class, my interface one, allowed. Okay, but the second parameter, what is allowed for second parameter is any class that implements my interface one. Okay, the first and foremost thing that we need to remember is there are two type parameters. One is class type and another one is interface type. Okay, interface type is very simple. Any class that implements this my interface one is allowed for interface type parameter. Interface type parameter. Okay, for class, right, there are different things. there are different combinations, extends and my class, and implements one of these interface or both the interface. Okay, let us try that one. Okay, so let us try this one. I will create one class that implements these two, one class that implements this one and this one and this one class that implements these three, and one class that implements only this one. Okay, all should be possible. Okay, that is just a 5 minutes work. Okay, so like my class 1. Okay, so I will do extend it, my class interface, I will add my interface. Okay, this is one. Okay, second one is I will say my class 2, which extends my class and implements my interface 1. Okay, and third one I will say my class 2. Okay, my class 3, which extends my class, implements my interface at my interface 1. Okay, and fourth one, let us say my interface 1 IMPL. Okay, that implements my interface 1 interface. Okay, it implements this my interface 1. Okay, so now we've got all the combinations. Okay, so now there is a type test. I lost track of that. Okay, so let us create one test class. Okay, test class test. So here we can create test class. Okay, so two things we have to specify based on whatever the thing that it is saying. We have to specify two parameters, type parameters. One is class type parameter, and another one is your interface type parameter. Okay, TC is equal to new test class of this one. Okay, so what are the options that we've got? We've got my class 1, my class 2, my class 3, and then my interface 1 IMPL. Okay, so let us try to assign one by one. Okay, whether it is possible. But in the second parameter, it has to be this one, my interface implementation. Okay, that is by default it should be there. Okay, okay, this is valid. Are you following the Kavita?
Yeah.
Okay, so here my class 2 and my interface. Okay, so it means okay, and this is one thing. This is not allowed. Okay, I will tell why. Third one is my class 3. Okay, okay, is it possible? To do that. So my class 2, what is my class 2? It extends my class at my interface 1. Okay, okay, so this is the definition. Okay, TC2 is allowed. So in any case, right? Okay, let me explain. So here my class one extends my class, okay, and it implements my interface. Okay, this is a valid type. Okay, here my interface one implements my interface one. Okay, this is my interface one. This is allowed. Any class that implements my interface one, that you can pass it as a second parameter to test class. Okay, but what are the valid values here? My class one, it extends my class
one
and implements my interface. Okay,
yeah.
And my class 2, it extends my class and implements both interfaces, IF1, IF and IF1, interface 1 and into my interface 1 and my interface. So if you see the definition,
interface right? 1, I think interface 1.
No.
Class
I have mentioned. Yeah, I'll tell you.
No.
Okay. So okay.
No.
So let's go to this particular definition. Okay. So if you might be knowing, so you click on that and just press Control and enter it. You can go to that particular class. Okay. The link will be created and you can go to that particular class. Okay. My class 1, it extends. This is we know. Okay.
Yeah. First class 1 I know. Class 2 it extends my class, but it implements my interface 1.
1, yes, that is not allowed. Okay.
Yeah,
this is not allowed.
Yeah.
This is not allowed. Okay. So that is why I commented it.
Yeah.
But here my class 3
implements both. Yeah.
Yes, implements both. So that means, where is that test class? Okay, that means in any case this condition should be there. Okay, and any class that implements is the minimum bound. Okay, my class and my class interface. It can also implement this interface, but this is the right combination. It should implement, in any case it should implement this one because we have specified AND. But if it extends my class and implements only my interface, that is not valid.
Yeah.
But it can implement, it can extend my class, it can implement my interface as well as my interface 1. Okay, so that is valid. But the one thing I was little surprised is, this is also considered as one argument, type parameter. This is also considered as one type parameter. That means if you specify, okay, multiple interfaces, if you specify, that means you are specifying multiple interface parameter types. That is what I can conclude from this, with this definition. Okay, we will see that one in our next session. We will see all those things. Let us cover other stuff, whatever we have got. Okay, if we discuss about interfaces, we will discuss about all those things. We will try all the possible combinations. Okay. Okay. So that is what about our classes and interfaces. And when specifying class type as well as interface type, we use ampersand operator. Okay, anyone has any other queries regarding whatever we discussed till now? Only Kavita is talking. Only Kavita is asking her doubts, or Kavita is trying to get her doubts clarified. No one else. Anyone has any other question? Okay, so we can use ampersand for specifying both class type and interface. When we specify ampersand, it means the classes which subclass this particular class as well as the interface, that you can pass as arguments, type arguments to that particular generic type. Okay, not sure why. Okay, so now let us come to this particular concept, that is wildcard arguments. Okay, wildcard argument is specified by using question mark. Okay, and it represents unknown type. It represents unknown type. So in which scenarios do you use wildcards? Can you tell me, Kavita? Do you know? So scenarios where, okay, let us take an example and we will start. Yeah, go ahead.
I mean, if you don't want to restrict to any of the class, you can put that question mark.
Oh, sorry. Yeah, go ahead, Kavita. Yeah. So there may be some situation. Yeah, go ahead.
I mean, if you don't want to give any restriction to any class, you can put that, I think so.
But that you can achieve without specifying bounded parent, right? Okay.
Yeah.
So when we specify unknown types, let us take one example. That is your stats example. So that's why I mentioned. I'll forget. So many classes are there. That's why I forget. I mentioned it. There. Okay. Excuse me. Let us go to this. Okay. And then where is that stats test? Did I mention stats test? Okay. So let us discuss about this. Okay. So here, what we have specified, the only types that are possible here is number. Okay. So what it takes, we have created. Yeah, I have a test also. So I have created one array of type this one. The valid values are any number, any type that are the subclasses of this particular number as well as number. Okay. This one. Since it extends, you can specify any type that are number and the subclasses of number. So P can be an array of anything. So we have a constructor, and here we are trying to calculate the average of all the numbers that are there in this particular array. Okay. So we can, I mean, for anything, what we are doing here, we can kind of like calculate the double value of each number and then find the average. This is perfectly fine. Okay. But what happens when we try to compare two objects? What happens when we try to compare the average of two objects? Here we are trying to calculate whether the two objects, the one which invokes and the one which is getting passed as parameter to the this method, same method. If what happens when we try to compare these two averages? Okay. Say for example, so let us take that. Yeah. So where is that class? Okay, here we have three arrays. One is 1, 2, 3, 4, 1.20, 2.0, and this one is third one. Three arrays are there. Okay. So we create three stats objects. One is integer, double, and float. Okay. And then we try to print the averages. Okay. So now, what is the definition of my same average? Here, I have specified stats is a generic, right? We have whenever we try to use stat, we have to provide some this one. What is that? Some type to that one. Attach some type to parameter type to. I mean type parameter to the stats class. So we can't just use without this type parameter. Okay. So here, whatever the type that I pass here, that will be here, right? So say for example, if it is integer, this has to be integer. Okay, this has to be integer. Same average we can invoke on integer object on integer object. That means here this is your integer object, this is your double object, this is your float object. Okay, according to our current same average method, we have specified stats T object. Okay, this is the parameter type that we have specified here. That means if I pass integer, right? If I pass integer, I can call this method only on integer objects. Because same average will become stats of int. Okay, this should refer to, this object should refer to integer object. Okay, if I pass double to this class, stats class, this will become double. Okay, so invoking object should be double, and then this should be, whatever you are comparing should be double. So what is happening? We have to compare only, we can compare only same object types. Object types. Integer means you can compare integer object with integer object. Double object means double object to double object. But that is not what we want. We should be able to compare. We should be able to compare any stats object which takes number. Okay, we should be able to compare the average of integer with the double with float, float with integer, not integer to integer, double to double, float to float, right? That is achieved using this method by specifying the wildcard. Okay, that is specified. Let us try this one first. Okay, whether we'll be able to do it or not. Okay, did you get it? Okay, let us do one more thing. Okay, let me create one more. Okay, here same average is showing error. Obviously, it has to show error because we are trying to compare int object with double object. That is why it is showing error according to our description. So whatever the way that we have defined this particular method, right, same average, that is why it is showing this error, because we cannot compare integer object. We cannot compare integer object with double object, average of integer object with double object. Okay, because that is what this statement means, this particular method means. Whenever you pass integer to this t, this will also become integer. So the definition itself changes. That means you can compare only same types. Okay, you can compare only same types. That is integer object with integer object, double object with double object, any other float object with float object, any number type. Okay, so that we can test it here itself. It was showing error with the integer object to double object, right? So now we can try with this thing. Okay, dot same average of int obj 1. We did not have to create another object. We could have compared with same object. Okay, int obj, sorry. Okay, so I have to create these things also. Okay, now this will be valid. Also, 1. This is also valid. Okay, and all these things are valid because of our definition. Because we are trying to compare two similar type of objects. We are trying to compare two similar type of objects. Okay, integer to integer, float, double to double, float to float. That is why it won't show any error. But that is not what we want. Our requirement is totally different. That means we should be able to compare average of integer object with average of double object with float object with integer object, what are other possible combinations. Okay, so that in such scenarios, when we are dealing with the class hierarchies, right, number, float, and then double, all those things are form a particular class hierarchy. So in such scenarios, right, we can use wildcard like this. Okay, so it simply means any class. Question mark means any class. This is a wildcard, right? Question mark means any class. Okay, but there is a difference. We cannot pass any class to that. Okay, whatever we specify here, right? Whatever we specify here, that is the number. Whatever we specify, I mean, this particular t extends number, right? We can pass when we specify wildcard. We can pass any argument or any type which is subclass of number. Okay, stats question mark means this particular context is already defined. What else you can pass? This is already defined by this one. Anything that extends number. Anything that extends number, that is what we can pass, not anything else. Number and its subclasses. Are you able to see the difference between this method and this method? Are you all able to see this difference? Or are you all trying to understand what we are trying to explain? Okay. So, excuse me. So when we just specify t, right, it is a generic type. So we have to specify something here with within some angular brackets. We have to specify something here. If we specify t, there is one more interesting thing that is happening. I will tell you that after this discussion. Okay. If we specify t, that means whatever you pass, type argument that you pass to this t, right, this will also become the same thing. So you can compare the averages of two similar objects. You can compare the averages of two similar objects when you pass t here. Okay. But when you pass question mark, any type you can pass. But what any type? Which subclasses of any type? This number subclasses of any type. It is also restricted. This context is defined already with this one. Okay. That is why only a type that you can pass here is number and its subclasses. Any subclass of number. Okay. So you can see the difference between this and this, right? Okay. Now there is one interesting thing I will tell you. Okay. Okay. So let us see what happens if we specify this one. Okay, let us comment this one. So will this work for our requirements? Can anyone tell? Anyone knows whether it works or not? Anyone knows whether it works or not? Yeah, that is what I expected. So Kavita said no, but it is comparing. See, integer object and double object, and you got the result. See, averages are same. So just by you could have seen that one. See, when I defined this, it was showing error. See here, it was showing error, and it was saying there is one other method which is defined in the same way. It says erasure of method same average stats is the same as another method in the type stats of T. Okay, that means this accepts any object. Okay, any object of type number and any subclasses of number. Okay, this also does the same thing. Without using this wildcard, you can just specify like this. That is valid. I guess I'm not sure. Maybe it is a feature of JDK 7, but maybe in 6 and all this is not allowed. Maybe in 6 and all this is not allowed because stats is not just any other ordinary class. It is a generic class. Okay, maybe after 7 they might have relaxed this particular thing. Okay, that is why this is working. So I have, I think, 1.7 in my system. That is why it is working. Maybe 1.7 after 1.7 they did that one. Okay, and there are also something called as wildcard, bounded wildcards. Okay, bounded wildcards. So as we have seen bounded types. Bounded types, how do we specify? Extends from superclass, right? Similar to that one, this is your wildcard. This is your wildcard, okay? Wildcard extends superclass, similar to our T extends superclass. Superclass and subclasses of that superclass, and say for example you have question mark, any class, okay? So let me write it in a better way. So we have T extends number, okay? T extends number. So when you use similar to what our same average did, sorry, that question mark extends some other this one, some other class A, OBJ. Okay. In this case, what are the types that are possible here? We have float, we have integer. Okay. We have any other things. Okay, double. Okay. So here, what are all the possible value types that we can pass? All these things and their subclasses. Okay, and here this is your upper bound. Superclass specifies your upper bound. For example, you want to calculate same average for only integers. Okay, you can specify question mark extends integer. Okay. Okay. So let me write that same thing, same average. same average, okay, with stats, I specify the upper bound, extends integer, okay, OBJ. So here what is happening? What are the types that we can pass here? Any class, okay, that extends integer. That means we can calculate only for integers and any subclasses of integer. No, it is not number, Kavita. So here we are filtering. So initially when we specified that T extends number, okay, T extends number. Here we are filtering only number types, okay. Here what are we filtering? We are filtering any class that extends integer, okay. That is what we are filtering here. So this is your upper bound, okay. In this case, we are using the keyword super and specifying subclass, okay. Anything above this particular subclasses are valid. Say for example, if I specify super integer, right? Integer, numbers and above whatever things are there, they are allowed, okay, but not integer. This is inclusive, this is exclusive, okay. Whatever the subclass that you specify, this is your including your superclass, this is excluding your subclass, whatever the subclass that you specify, okay. I think yeah, that is the end of today's session. We will continue with this generic in tomorrow's class. I thought I will complete it today. So this is a vast, this is a lengthy chapter. Okay. So anyone has any doubts regarding this one? Any of the topics that we discussed? Let me know. We can discuss. Otherwise, we can. Yeah, we can wind up this session. Okay. Kaita, do you have any questions? Your hand is still up. Okay. Yeah. So if you have any doubts and if you need some clarifications, please let me know. We can kind of like discuss the same topics again, whatever we have discussed again, because this is one of the important topics. It is one of the important topics, and it is very important to understand these generics. Okay, that is right. Okay, so looks like no one has any questions. We will stop this session, and we'll continue tomorrow at 8:30. Okay, tomorrow 8:30 p.m. CT. Okay. Thanks everyone. Yeah, enjoy your evening. Bye. Thanks, Tina.